Good morning, students. In this module, we are going to learn about velocity time graphs. In velocity time graphs, we take velocity on y-axis and time on x-axis. We should remember that in graphs, speed and velocity are considered same. They have the same meaning. If a body has constant velocity, does the body have acceleration? The body is having constant velocity. So the change in velocity will be 0. That means its acceleration will be 0. Now let us consider the velocity time graph for a body with constant velocity. You can find the graph to be a straight line parallel to time axis. The slope of the velocity time graph gives acceleration. Do you remember the formula to calculate slope when you have 2 points on the graph? Slope is given by the formula y2 minus y1 by x2 minus x1, where x1, y1 and x2, y2 are the coordinates of 2 points. Consider any 2 points 2, 40 and 3, 40. Let us take these 2 points. Then acceleration is equal to y2 minus y1 by x2 minus x1. Substitute the values in the formula. We will have 40 minus 40 by 3 minus 2, which will be 0. So a body is moving with constant velocity is said to have 0 acceleration. We have shown that body has 0 acceleration. And the velocity time graph is always a straight line parallel to the time axis. Do you remember the formula to calculate distance when you know velocity and time? Distance s is equal to velocity v into time. S is equal to v into time. Let us calculate the distance covered by the object between 2 points A and B. We have already seen the formula S is equal to V into T. Now the velocity here in this graph is 40 km per hour and time is T2 minus T1. If you draw perpendicular from the points A and B on the graph to the time axis, we can find that AC represents the velocity. AC represents the velocity and T2 minus T1 is represented by CD. So we will get distance S as AC into CD. Means instead of 40 we are taking AC and instead of T2 minus T1 we are taking CD. This AC into CD is nothing but the area of the rectangle ABCD, where AC is the breadth and CD is the length of the rectangle. So we find that the area of the figure enclosed by the velocity time graph with the time axis gives distance. So from the velocity time graph, we can know about 2 aspects. The first one, slope of the velocity time graph gives us acceleration. The second one, the area enclosed by the velocity time graph with the x-axis gives distance. Now look at this graph. How does the graph look like? It is a straight line passing through the origin. Calculate slope of this graph taking 2 points. Let us consider 1, 20 and 2, 40. Slope is given by the formula y2 minus y1, x2 minus by x2 minus x1. So we will have 40 minus 20 by 2 minus 1, which is 20 meter per second square, because the slope gives acceleration. So it is 20 meter per second square. Take another 2 points, 2, 40 and 3, 60. Calculate slope again. We will get the same value. That means the body is having uniform acceleration, because the velocity is changing by equal amounts in equal intervals of time. The velocity time graph for a body having uniform acceleration is a straight line. Now, let us see how much distance is covered by a body having uniform acceleration between the points A and E on the graph. Drop perpendicular from the points A and E to the time axis. The perpendicular from the point A will meet the time axis at B, and the perpendicular drawn from the point E to the time axis will meet the time axis at C. Draw two more perpendiculars from A and E to the y-axis. We have already learnt that the area enclosed by the velocity time graph with the time axis gives distance. So here the area enclosed by the graph AE, the part of the graph AE with the x-axis will be the area of the figure ABCDE. This figure ABCDE can be divided into two parts, where you will get a rectangle ABCD and a triangle ADE. So we can write the area of the figure ABCDE as area of the rectangle plus area of the triangle. I think all of you know the formulas to calculate area of the rectangle, which is L into B, and area of the triangle, which is half into base into height. Now, the length of the rectangle ABCD will be BC and the breadth will be AB. If you consider the triangle, the base of the triangle ADE will be AD and the height will be ED. So, we can substitute the values in the formulas and calculate the areas of both the figures and add them. So, we will get the total area of the figure ABCDE. What does it give us? It gives the distance covered by the object between the 2 points A and E. Now let us see how the velocity time graph looks for a body with uniform retardation. Do you remember what is retardation? Whenever the initial velocity u of the body is more than the final velocity v minus u value will be negative and the acceleration is negative. Then it is said to have deceleration or retardation. In the graph, you can find that the initial velocity u is more than the final velocity v. The graph is sloping down and it is for a body having uniform retardation. It is retarding by equal amounts in equal intervals of time. It is having uniform retardation. I think now you will be able to tell what is represented by this graph. Is it a straight line? No. So here the object is not having uniform acceleration. The velocity time graph is a curve and this represents non-uniform acceleration. Here the body is accelerated by unequal changes in velocity in equal intervals of time. So the velocity time graph for a non-uniform acceleration will be a curve and not a straight line. The graph here which is shown is of an object having non-uniform retardation. Here also, if you observe, the initial velocity u is more than the final velocity v. The initial velocity u, if you observe on the graph, the value is 80 meter per second, whereas the final velocity, with time the velocity went on decreasing and the final velocity became 0 in the 4th second. So here the velocity is decreasing. The initial velocity u is more than the final velocity v. So here it is retardation, and also the velocity is not changing by equal amounts. It is changing by unequal amounts. You have non-uniform retardation here. I hope all have understood about velocity time graphs. As we have already discussed, we will have two important aspects in velocity time graphs. The first one, slope of these graphs will give acceleration, and the area enclosed by the graph with the time axis will give distance. With this knowledge of velocity time graph, we are going to derive certain equations relating u, initial velocity, v, final velocity, t, the time, a, acceleration, and s, distance. We are going to derive few equations which relate these terms in our next module.